Hey, listen, welcome back, everybody. In our attendance, we got Maximus, Celeste,
Hi.
and Marcus. All right. Okay. Now, hey, today we're going to be covering this concept, and let me screen share it so you can see it. It's something that's going to be new in some aspects for some of you, and for others, it's going to be like something just makes a lot of sense. Now, I have two words here highlighted already. You see the perimeter and area words that I have highlighted? Okay, that means that we're now going to be looking at perimeters and areas of similar figures. So with that, Celeste, go ahead and read the vocabulary term for similar figures.
Two figures that have the same blank, but not the same blank.
Okay, Celeste, what are those blanks?
I'm guessing shape, but not the same size.
Excellent. Yeah, because anytime you have similar figures, they're going to be like this, they're going to look the same, but they're just not going to have the same size. Now, the thing that we're going to discover is that we have the benefit that they're going to have a relationship that exists between them. So, Marcus, go ahead and read the next vocabulary term, which is changes in dimension.
A proportional dimension change multiplies every dimension by the same value. Under a proportional dimension change, the image of a figure is similar to its pre-image.
Okay, good. So, what is this 1.5 saying?
A change?
Yeah, by how much?
1.5?
Yeah, so that means that when you're looking at a change in dimension, it's direct. You just multiply it exactly the same. You see how it's on both? Okay. And the same goes in when you add it or you multiply. The thing that's most important is that it's direct. Like it just happens. So if you add 2, you add 2 to all sides. If you multiply by 2, you multiply by 2 all sides. Okay. So now let's investigate a little bit. Now, there is a difference though. Is adding, okay, let me ask this important question. Is adding and multiplying the same?
No?
No, right? Okay. There is a profound difference, isn't there, between both?
Yeah.
In a way, and they're related as well. And that's one of the things we're going to discover. So in order for us to find out the benefit of how it changes, I'm going to explore perimeter first, and then afterwards we're going to explore area. Okay, so Max, tell us, what is the perimeter of the small one? Yeah, the small square you see here. What's 14? The total? What's the perimeter? Yeah, 14 centimeters, right? Okay. Marcus, what is the area?
10.
Yeah, 10 centimeters squared, correct?
Yep.
Okay. All right. Now, Celeste, tell me, what is the perimeter of the big one?
The perimeter is 42.
Yeah, actually, you're right. 42, right? Okay. And then, Marcus, what is the area of the big one?
Area of the big one is, what is that? 80?
Actually,
90.
it's going to be 90, right? So 90 centimeters square. Okay, good. Hey, so let's look first at perimeter, and let me highlight that for you. So we're going to look at this. All right. So Max, what is one thing you could guarantee me, or you're able to prove, that happens between this perimeter right here, the one I'm kind of like highlighting bigger, compared to the next one that we found on the similar shape? Can you share something with us?
Say that again?
Yeah. Can you share what is it that this perimeter, the one I'm highlighting, what relationship exists between the one the small one to the big one?
They're the
So
same shape but not the same size?
Yeah, so that proves that they're similar, right? But tell me something more specific that I'm looking between the 14
That they're
and
both centimeters?
Well, they're both in centimeters, good, but I'm looking for more. Celeste, can you help out your brother? What's something that you could tell him?
I noticed 14, you can do 14 times 3, which is 42.
Yeah, that is exactly right. That's great. Okay. And Celeste, is there a reason why, is there anything in 3 that kind of like, that you came up with? Or why is it that you came up with 3?
Well, so when I was looking, when you were talking, I noticed 5 times 3 is 15 in the bigger one, and then 6 times 3 is 6 on the bigger one. So then I thought the 14
Oh,
centimeters
okay.
must be
So you
done.
looked at the sides. So like, let's say 2 and 6, right? And then you also looked at 5 and 15. And you discovered, actually, one of the things that you discovered was something very important. You discovered scale factor.
May I ask a question? What is a scale factor?
Like the scale factor is like the thing you were noticing. You know the 3? Okay. So in this case, you found out that the scale factor, and let me highlight it, between the 2 and the 6 was 3. You multiply it by 3, you get the scale factor, right? Now, and that's exactly how, and then it exists also for perimeter. So this perimeter that we have here, 14, gets multiplied by 3, and as a result, we get the 42 scale factor. Now, does anybody remember the equation for scale factor? Do you know? Were you going to tell me no?
Power of 2.
Well, if you always remember
wait.
no, n divided by no, and n, okay, you will always remember scale factor. And actually, let me change this up.
New divided by old.
Yeah, new divided by old. If you have new divided by old, you will always know scale factor. So you see how this is the new figure? And you can take anything. You can take the 42 divided by the old, which is 14, you come up with 3. Or you can take the 6, which was one of the sides right here, and divided by 2, which is this other side, and you still come up with 3. So you see how we have new over old? So new over old is very beneficial in order to find scale factor. And anytime you have similar figures, you're guaranteed a scale factor. So what I want you to do next is this, okay? I want you now to, now I want us to explore area though. Now, Marcus, tell me, is there a relationship that you could discover between the 10 and the 90?
10 and 90.
Yeah, give me a relationship that you could tell me.
10 times 9 equals 90.
Yes. Okay. Do you know how
And
do you know how you could relate that to scale factor?
well, 90 divided by 10 is 9. But since the scale factor is 3, we would have to take 9 and get the square root of it, which is also 3.
Yes, actually, there's a very important tip I want to share with everybody. But listen, I'm going to go ahead in order to show this tip. Let me erase all this because it's like very messy. And what I want to do is I want to just focus on something that's very important and very beneficial for you, because what it will do is that it will actually help you. So you know how we said, Marcus, remember how we said the area of this was 10, oops, hold on, let me get back to my pen. You said it was 10 centimeters squared?
Yeah.
Okay. And you said that this area over here was 90 centimeters squared?
Yeah.
Okay. All right, good. Well, one thing you're guaranteed, and this is, and remember we said that this perimeter was like 14, but it was just centimeters? Okay. When it comes to scale factors have the benefit that they're going to follow the power that you see here. And actually, let me do it in yellow. So you see this square? So you see the square? Okay. So what's the exponent for centimeters?
Wait, 1.
1, right? Okay. So we don't do anything to the 3. So you know how we found out the scale factor was 3? Okay. So that's why these kind of measurements have a direct effect. But when you see the square, you also need to take the scale factor and square it. So this is how you could guarantee that's going to be 9. And then from there, you could do 10 times 9 and come up with that amount. Does everybody notice that? Okay, but it all initiates with looking at the units. That's where it becomes very important to look at the units, and then you can see the relationship, how area affects it all. So all these boxes kind of talk about the same thing. Rectangle's 3 times bigger, and perimeter's 3 times bigger, but the area is square. All right, excellent. Okay, so now we got all our tools to actually start solving our problems. Okay, so let's go ahead and actually start with this one. All right, so Max, go ahead and read the directions on example 1.
The figure in each pair are similar. Compare the first figure to the second. Give the ratio of the perimeter and the ratio of the area.
All right, good. Okay, so Max, so you see when they're asking for ratio, what's another word for ratio?
Like in total or something?
Well, another thing that you could talk about ratio is that they're also going to talk about scale factor. Okay, so let's go back. In this case, Max, what is, how do you find, what's the equation for scale factor?
New over old?
Yeah, new over old, right? Okay, good. So in this case, now, you have the benefit that you could use whichever one you want to be new over old. So we'll do this one. All right, so Max, when you do 12 over 15, what would this reduce to? What's the largest common factor? Yeah, Marcus is raising a 3.
No, 3, right? 3.
Yes, 3. Okay, so then what amount do you get as a result?
So you get, that one is 4, another one's 5.
Yeah, so that's basically a ratio. Now, the only thing that's new about when sometimes you see ratios, they're not written in divisions, they're written as, and in this case, it's something like this. And you'll see here in the blank. So you see how we got the scale factor, 5 over 4?
Mm-hmm.
And then in this case, the ratio of the perimeters is 5 over 4. Oh, they also wanted the ratio of the areas. All right, so let me cover this back up because I want to challenge you a little bit. All right, so in this case, in order for us to, let me erase this part. In order to do this, and let me do it in green. So we could, so you could focus. Okay, so how would I find the ratio of the areas? Can anybody lead me through it?
Well, you would first have to find the area.
Well, remember, scale factor is.
Oh, yeah, you could just square 5, I guess.
Yeah, you could square both of these.
Yeah.
Because remember, you have a scale factor, right? The only thing is that they wrote it the other way around. They decided to call this one U. Let me see if I can move it. No, I can't move it. In the notes, they decided to call the left one U and the right one old.
Okay.
Yeah, so they just did this one U over old. So you still get the same ratio because you could flip around ratios. The only thing is that now they squared it. So what is 5 squared? And 4 squared is 16. Okay.
15.
So you could reduce this again. So what is when you reduce it, what's the greatest common factor? Actually, does it have one?
Yeah, it doesn't have one.
I don't think it has one, right? Yeah, so let's go ahead and show this. Yeah, so it is 25 over 16. All right, good. I think they're gonna probably follow suit on these notes. So most likely this is gonna be new and this is gonna be old. All right, so Marcus, go ahead and do this next one. What's the scale factor?
2.
Not according to you over old. Not in this one. Because you see,
1/2.
Yeah, because they decided to do the other way around.
Okay.
Where that's the reason I wrote N here and O there. All right, good. Now, what is the perimeter, Marcus? What would be the perimeter scale factor?
Perimeter scale factor.
Well, yeah.
What do you mean?
Well, it'll still
Yeah,
be a
1/2.
half. Yeah, still 1/2. Now give me the area.
The area?
Yeah, the area. Like what would
That would
be
just
area
be
difference?
1/4.
Yeah. Okay. Now this is important. That means that whatever, when you're looking at this area scale factor, Marcus, what's the best way to explain what is happening then? Like if you're
It's
going to give
getting
me an
squared.
example. Well, like let's say that this is 32 inches squared. It means that this is going to be 8 inches squared in the area. You see the difference?
Yeah.
Because we're going from 1/4. So that's the biggest difference. So if you notice, it's not a direct thing. A direct is a half or 2 from 4 to 8, right? Here, it's a difference of 4. So that's the biggest thing of how the area affects scale factor as opposed to perimeter or length. All right, good. Okay, hey, now let's do the last one. Remember, this is new, Celeste, and this is old. So what would be the scale factor on this one?
Well,
This one's going to be a fraction, 12/5. Okay, and then the perimeter will still be 12/5. What about the area?
the area will be 144.
Yeah, over
144
25.
over 25.
Excellent. All right, good. Okay, so now let's move to example 2. Marcus, go ahead and read example 2 for us.
The figures in each pair are similar. The area of one figure is given. Find the area of the figure to the nearest whole number.
All right, excellent. Okay, so they give you the area of one of them. So the area of the smaller figure is 54. Okay, so Marcus, how can I go about solving this?
Oh, okay. So first we would have to find the area ratio. So what do we do?
Okay, well here, let me give you an easy and quick way to do it. Okay, so we don't know what this
Is it
is,
still
right?
new or old?
Yeah, it's going to be related to it because, see, in this case,
Oh,
this
okay.
is
I see what you
inches
mean.
squared.
Yeah, just put. Yeah.
Okay, now, how do you know which one's the new one and which is the old? The one with the
Dotted line?
X will be the new, and the
Okay.
one you have the stuff, that'll be the old. Okay, so what you do is this. When you find scale factor, okay, you're going to do 28/16. Okay, and then from there, this reduces, Marcus. So what does it reduce to?
7/4.
Yeah, because the greatest common factor is 7/4, right? All right, good.
Yeah.
So if you took 16 and multiply by 7/4, you're going to get the 28. That's because that's scale factor, right?
Yeah.
Okay. Now, how would I go ahead and find area?
You would have to square 7/4.
Yeah, we're going to have to square both of these, right? So as a result, what's the scale factor squared? What's the area scale factor?
49/16.
Yeah, 49/16. And then what do I do from there?
You would times 54/1 times 49/16.
Yeah, exactly. So 54 times 49/16, because this time this is a scale factor squared. And then as a result, I'll get x. Now let's see how much x is. Oops, there it is. And they set it up too, but they set up as a proportion. It's much more, I don't want to say involved, but there's much more in play here than just doing it the way we do it. But one thing that I'm able to guarantee you is this, that if we took this amount and multiplied all this out, I would get this amount. Make sense? That the amount 54 times 49 divided by 16 is going to give me 165.375. Does it make sense for everybody?
Yeah.
No? Well, here, let's see. Celeste, where did I lose you?
Well, where you lost me was when you did like, why did you do like 28/16 and then equals 7/4?
We reduced it here. Because see, you could reduce a fraction. You just have to find the greatest common factor. And I'm glad you brought that up because you're probably not the only one I lost who was watching this video. We divide by 4 here. So 28 divided by 4 is 7. 16 divided by 4
Oh, now I
is
see. Okay.
4. Okay. Does everything else make sense?
Yes.
Why we squared it, everything else. All right, good. Excellent. Okay. So now, Max, do the next one for us. Well, actually, let's do this. Let me give you the larger the area of the larger rhombus is 500. So this one's 500 and this is meter squared. All right, so Maximus, lead us through how do we solve this one?
So the greatest scale factor is 5 for 25 out of 10.
No, Maximus, listen, stop. All right, this is new and this is old.
Mm-hmm.
Now, why did I pick that? Okay, wherever your X is, that's the one you picked for new.
Oh.
Okay, so now keep on going. What do I do next?
10 over 25.
Excellent. 10 over 25, which reduces to how much?
2 over 5.
Yeah, good. And Celeste, look, we divided by 5 to both sides, okay? Top and bottom. Okay? All right, and then what do you do next?
Then you do 500 over 1 times 2 over 5?
No, you got to square it because see, remember, we're given the area and squared. So in order to translate the scale factor to area, you square it.
Oh.
Okay, so then as a result, you'll get 4 over 25, right? And then we do 500 times 4 over 25.
Gotcha.
Okay, so that amount is going to be 80. And probably is because look, 500 times 4, that's about 2,000. 2,000 divided by 25, 80. Okay, so, all right, good. Now let's go ahead and work on the next ones. Celeste, why don't you go ahead and read example 3.
Okay, but Daddy, I didn't like what did you mean?
Oh,
Whoever has the X.
Yes. You see how this one is the unknown value right here, Celeste? This one? Let me put the X right here. They were looking for the area of the smaller one. And the reason being is because it gave you, oops, hold on. They gave you the area, and let me erase some things here. Because there's a lot of stuff happening
Oh,
here.
now I see. Okay, thank you.
All right, good. Okay, and that's because they give you the area of the larger one, so they wanted the area of the smaller one as a result. Like in this one over here, in this other example A, they had given us the area of the smaller one, and they're looking for the area of the bigger one. So that's how you know how to place new over old. Like on this one, I didn't highlight it, but new goes with the X. See how I highlight that now? Okay. Now let's go ahead, Celeste. Go ahead and read the example 3.
Example 3. Okay.
Yeah.
The scale factor of 2 similar polygons is given. Find the ratio of their perimeters and the ratio of
the areas. Okay, good. So for each of these, on this one, you just have to reduce it. So Celeste, what is 9 divided by 3, or 9 over 3 reduced?
3, because 9 divided by 3 is 3.
Yeah. Well, it'll just be 3 over 1, right? Now, if you took this and squared it, okay, what would be the amount?
9 over 2.
9 over 1, because 1 times 1 is 1.
Oh.
All right.
Oh, okay.
Marcus, so do the next one for us. Do 10 over 4.
Okay. So perimeters will be the ratio of blank. What?
It would be 5 over 2 because you could go ahead and reduce it. And then what about the area?
Okay, well, the area would be 25 over 4.
Excellent. Yeah. All right, Max, do the last one.
Oh, I gotta do it backwards. Okay. Number 4 will be 1 and 20 will be 5.
Okay, 1
So
over
1
5
over 5.
reduces, right? And then give me the areas of the ratios.
So that'll be 1 and 5 will be 25.
Good. So it would make it 1/25 size. All right, excellent. Okay, let's go to the next page.
There's another.
All right, Celeste, go ahead and read the example 4. What does example 4 say?
Okay, find the scale factor and the ratio of perimeters of each pair of similar figures.
All right, excellent. All right, so let's see what this is. All right, so Celeste, how would I do this one? Actually, there's something that's kind of new about this one. Why is this one different? Here, let me show you. Yeah.
Oh, isn't that 12?
They give you the areas, right? Okay, so we're gonna work backwards. Hey, what's the opposite of squaring?
Square rooting.
Yeah. So now we're gonna take the square root of these. So the scale factor squared, when I wanna just find the scale factor to find the perimeter, it's gonna do the other way around. So we have 8 over 98. Okay, we're gonna take the square root, in this case, of each one. And as a result, we'll get, it's really going to be the square root of 8 over 98. And I think that could reduce. Let's see what they did. Yeah, you see how they do square root of 8 over 98? It reduces to 2 over 7. Okay.
I think you need a calculator for this one.
Well, most likely, I think what happens is this. This one goes ahead. This becomes 4 over 49. And then when you take, you could separate each one. Square root of 4, square root of 49. And as a result, you get 2 over 7. So you see the progression. Square root of 49, and then you take the square root of each one. So let me highlight it, what I did. I went from here, and then I reduced it here. And then after that, I took the square root and separated them. So you see how they're separate right here?
Okay.
Then afterwards, I applied each one. Okay? Does anybody have any questions? No? Okay, good. Okay, let me do the next one. Or let's do the next one. Hey, Celeste, can you hear me?
Yes.
Okay, Celeste, somehow your video came out. See if you hit some video button on your thing.
Oh, yeah, I did. I'm sorry.
All right.
It's just that my computer's starting to lag because it's starting to get heated up. So that my screen is getting laggy.
So, Marcus, go ahead and lead us through this one. What would I do in this one?
Okay, so 2 circles, the areas of 27 pi and 48 pi. So we would just square root them again because they're both squared, inches squared.
Okay, so we will do this.
27 over 48. Both could be divided by 3 to get
what about the pies?
9 over pies. Those guys could just stay there. Actually, no, they cancel out.
They cancel out, right? Okay, and you still take the square root of both, right? And then you said that they reduce to how much?
9 and 16.
Good. And then what happens after that?
Well, since they're getting square rooted, they become 3 and 4.
Yeah.
Daddy, my computer is starting to lag very much.
Okay, no, that's all right, Celeste. Just if I need you, I'll tell you. I'll have you chime in on audio. Okay. So if you notice, so yeah, absolutely correct. All right, Max, do the last. Maximus, go ahead and do the last one. Oops.
This seems the hardest.
It's not so bad, actually. What would you do?
No, I'll first get 8 square root 3 over 128 over 3.
Yes. Now, hold on a second. Let me get my pen. I've been selecting highlighter. All right, so in this case, scale factor squared is 8 over square root of 3 over 128 over 3, right? Now tell me something you
Yep.
discovered, one thing you're able to prove.
That can 4 go into it? Is that the scale factor? I'm not sure.
Well, first of all, the square root of 3's cancel out because they're the exact term. And then afterwards, you could go ahead and divide actually 8 into each one.
Oh, so that means the top one's
Yes.
1 and then
Yeah. So
I
you
don't know.
notice,
No clue
so it
how many
becomes
times
1. Well, actually, right before this, the only thing that's missing from these notes that will probably been beneficial is that this would have been square root of 1 over the square root of 16. That basically this amount right here reduces to 1 over 16. And then as a result, you get 1 over 4.
Okay.
All right. Hey, listen, let's work on the very last problem. So with that, let's have Marcus, why don't you go, let me scroll down a second. It's not, oh, now I know why. My little pen has a timeout and it had timed out a little bit. All right. So Marcus, go ahead and read example 5.
It takes 12 hours to paint a 10-foot by 18-foot mural. At this rate, how long would it take the same number of people to paint the same mural on a 15 by 27-foot wall?
All right, good. So any ideas how to solve this?
Yeah, you just use the ratio thing. So you first find the ratio of the perimeter, then find the ratio of the area, then you times the ratio of the area to 12.
Yeah, so which, I know, but in this case, which one would you use? The area scale factor or the perimeter scale factor? The area one?
Yeah.
Let's find out.
Bada bing, bada boom.
You are right. Did you use the area one? They did. Yes, that's the one. And they use this. They just set up a proportion and solve for it. All right, excellent.
Yeah.
Okay. All right, kids. Hey, listen, thank you so much for being with us. I hope you enjoyed this video. Go ahead and write notes. And everybody say bye.
See ya.
Bye.
All right, thank you.